All right. Well, last but certainly not least is Dr. Phil Plait. He is an internationally renowned astronomer, author, and lecturer. He has appeared numerous times on radio, television, podcasts, and many times in front of a live audience. He is quite a celebrity in scientific circles. His writing has appeared in dozens of magazines. His first book, Bad Astronomy, that's how he gets his nickname, the Bad Astronomer, was a trade science hit, and we do have it for sale out in the hallway. He's delighted audiences around the United States and Australia with his lectures about astronomy, science, and the fight against pseudoscience. He is also the head science writer on Bill Nye Saves the World TV show, which is airing on Netflix Friday, correct? Friday.
That drops Friday, I believe, as the kids say these days.
Right. So check that out. So without any further ado, I'll go ahead and turn it over to Dr. Plait.
Thank you. Thank you. It's really nice to be back in Kearney. I was here 5 years ago, or 6 years ago, I guess now. And it's pretty cool to be back, and especially talking about such a great event. I love this picture, but I'll show it to you again. We've talked about an eclipse, so it's probably time to talk about what an eclipse is. And there are lots of events where objects in the sky pass in front of other objects, and we usually call these transits. But when the two objects are similar in size, apparently, like the sun and the moon are, we call it an eclipse. So the ingredients you need for an eclipse are A, the sun. This is actually a photograph I took a couple of years ago through a small telescope. And yet you can actually see there's a little prominence, a little eruption of gas off the side. I was very fortunate to be able to catch that, as you had mentioned in the earlier picture. Yeah, those are still going on after 100 years, so that's pretty nice. A different prominence, but what the heck. You need the Earth, and that's important because that's where we live. And without the Earth, we won't be observing this. And you need the moon. In the case of a solar eclipse, the moon passes directly in between the Earth and the sun. And when it happens, the moon slowly passes in front of the sun, eats more and more of it. It's not a dragon, it's actually a gigantic ball of rock. And then for a short period of time, it blocks the sun's face entirely. And then it moves off again, then you get the whole eclipse again in reverse. Now the reason this happens is because the moon orbits the Earth once a month. And as it does so, in this case, it passes in front of the sun. And one of the most common questions I get about this is, why don't we get an eclipse every month when the moon passes right between the sun and the Earth? And the answer is because it doesn't. The moon's orbit actually, the moon's orbiting the Earth, and it's passing directly in front of the sun. But the moon could orbit the Earth this way, and then it would almost never pass in front of the sun, or it could, be tilted at some angle. And the reason is it's tilted at a slight angle to the path of the sun in the sky, about, at least to the Earth's equator, about 5 degrees. And it's not much. It's a very slight tilt. But what that means is sometimes the moon passes above the sun in the sky and sometimes below it. That's what usually happens. And because the sun and the moon are small in the sky, it's very easy for them to miss each other every month. And it's only when things line up just so that you get an eclipse. And I love this graphic that I stole from NASA, and I believe if I click this again, it'll start. There we go. So the sun is off to the left in this diagram, and the moon is orbiting the Earth this way, and you can see the shadow of the Earth and the shadow of the moon. Now, usually the moon misses the sun, and the shadow of the moon passes above or below the Earth, just like in this drawing here. But over the course of the year, as the moon is going around the Earth over and over again, everything lines up just so, and the moon's shadow passes in front of the Earth. Now look at how narrow that cone is, right? The Earth, this is to scale, amazingly. Most diagrams like this aren't to scale. The moon is teeny weeny, and it's really far away. And so the narrow part of that shadow just passes over the Earth in an eclipse. And I can show you a little bit more about what this is going to actually entail for us on planet Earth on August 21st. We've talked about ancient eclipses, medieval eclipses, relatively modern eclipse. 100 years ago, you know what, I'll give that credit. That's a modern eclipse. We had telescopes. It's a modern eclipse. Now we've got this. I guess this is in the future, so it's a postmodern eclipse. And so here's another graphic by NASA. Now, mind you, for a total solar eclipse, the sun has to be up. right? So only half the Earth gets to see one of these things, and you have to be in the right spot on the Earth at the right time. Now, what you're going to see here is a series of darker and darker shadows. There's a lot of stuff going on here that we don't have really time to talk about, but during the partial phase, as the moon is starting to block the sun, you're still getting the shadow of the moon on the Earth, but you're not blocking all of the sunlight, and so you're getting sort of a lesser shadow. We call that the penumbra, the almost shadow. And that's what these darker circles are. And so we'll start this up. And then as the moon moves into position, the umbra, the darkest part of the shadow, moves into the picture. And so everybody on this red line is going to get a total eclipse. And you can see it comes in off the coast of Oregon, moves into Idaho, Wyoming, and then, hey, look, that's us here, Nebraska. And then some other state, I think that might be Missouri, I don't know, who cares? Tennessee, maybe, I can't tell from this angle, and then South Carolina, and then off into the Atlantic Ocean. Now, if you're on that line, the sun will completely block the face of the moon. If you're even a little bit off that line, it won't. And you'll miss it. You'll get a mostly total eclipse, but unlike Princess Bride, that mostly is a bad thing. This eclipse is mostly dead. In fact, it's just dead. You won't get the amazing total solar eclipse, which I'll talk about in just a moment. What does that mean for us here in Nebraska? Excuse me, before I get to that, here is a static map. That's right, I wanted to show you this first. The red line is the center line, and the blue lines represent the total eclipse. So if you're in between the blue lines, you get a total solar eclipse for some amount of time. If you're on the red line, you get the maximum amount of time, because then the moon is passing directly in front of the sun. Things are lined up just right. And so it turns out in Nebraska, that's pretty good. As you can see, actually, let's see, there it is, Colorado, where I live. Yeah, out of luck. I can't see it for where I live. I'm going to have to drive up into Wyoming, western Wyoming, to be able to see this. That's actually a really good spot to go because it'll probably be clear in August. I don't know what the weather's like here. But in a lot of places, hot. Is that weather? Or is that just, I don't know, is that just temperature? Hot is fine if it's not, pouring rain or hailing, or you may get tornadoes here. I've heard about that in Nebraska. So hopefully it'll be clear. I know on the East Coast, August can be touch and go. Hopefully it'll be clear there. So here in Nebraska, I made this this map. You can find this map online. Just type in August eclipse Google map or something like that. This is an interactive map. You can click on it and it will tell you how much of the eclipse you'll see there and how long it is. So in between, again, those two blue lines is where you can see a total solar eclipse. So if you live in North Platte or, for example, Kearney, you will get a total solar eclipse. The closer you are to the center line, the longer it will last. And so, for example, Grand Island is probably your best bet from here. You can just drive right up the highway and boom, you get the maximum eclipse. So as you saw in that graphic, the moon's shadow is going to come into the United States over Oregon, and it moves sort of southeast and goes over South Carolina. So it's going to enter from the upper left there and take about, I believe it's about 20 minutes to cross Nebraska. If you're on the west side of Nebraska, the total eclipse will last from 12:46 and 53 seconds to 12:49:22. This is local time. So you can see it's only about 2 minutes long, something like that. If you go to the other end, over by the Omaha end of things, it'll start at 1:04 and end at 1:07 and some seconds. So again, about 2 minutes. And this is maximum. I clicked actually on the Google map. This is my highly scientific method of doing research. I clicked on a map twice and wrote down the numbers. But it is replicable. You can do this as well. And for Kearney itself, the eclipse will start at 12:57, and it could be 30 seconds, it could be 36 seconds after the hour. It really depends on exactly where you are. So don't give too much faith into these numbers. I just wrote them out to the second so that you can see that you'll probably get just under 2 minutes of eclipse here. If you want another 10 to 15 seconds of eclipse, you can drive up to the northeast and get that much more. In my opinion, totally worth it. I would do that for an extra few seconds. On the other hand, you can walk outside. Or, you can be doing the dishes and looking out your kitchen window at the eclipse. Something to be said for that. Especially somebody like me, I'm going to have to drive like 17 hours to the middle of Wyoming to see this thing. So what are you going to see? You're going to see this. This is magnificent. as the moon is covering the sun, the sun is still so bright, every bit of the sun's surface is so bright, that all you're going to see is sort of this crescent sun getting narrower and narrower and narrower. And then once the moon completely blocks the sun, the upper atmosphere of the sun becomes visible. This is called the corona, and it's way too faint to see during the day. It's even you can block the sun with your hand or whatever. It's simply too faint to see unless it's blocked very far away and the sunlight doesn't even get to the ground. And so that's what the moon is doing for you. It's blocking the bright sunlight and letting you see this corona. Mind you, if we didn't have eclipses, we wouldn't have known this existed until modern times because we didn't have the technology to do this. And you can also see around the surface of the sun there, around the edge of the moon, these pink spots. These are prominences and clouds of, well, not clouds, but towering gas on the surface of the sun that normally we can't see, but you can as the moon blocks them. This is what I'm really looking forward to seeing. What about other effects you might see? And look, you can go online and see a bazillion pictures of solar eclipses. They're everywhere. I'm actually curious about other effects. As the moon blocks the sun, it gets dark, it gets cold, as we've mentioned. Birds will start chirping like it's getting to be twilight. Crickets will cricket, I guess. I don't know. I already said chirping. They'll rub their legs together. They'll be looking for love, and that's what they want to do when it starts to get cooler at night. But remember, it's the shadow of the moon passing over the Earth. And you can see that in this photograph taken in an Australian eclipse in 2012. That dark triangle is the shadow of the moon on the Earth's atmosphere. To the left, you can actually see where the air is being lit by the sun. But that gigantic wedge is the lunar shadow passing over the Earth. That is something I am very much hoping to see. Apparently from an airplane you can see this really beautifully. And there's an advantage to an airplane ride as well. You can follow the path of the sun. Now that's moving way too quickly to actually catch up with and stay going with. But if you're in an airplane, you can actually follow the shadow of the moon. Excuse me, I said sun a moment ago. You can follow the shadow of the moon and actually extend the length of the eclipse. In this case, you could go from 2 to say 4 minutes. And from what I hear from friends of mine who do that, who call themselves, by the way, umbraphiles, shadow lovers, it's totally worth it to do this, even though a friend of mine's been begging me to do it, and it's a chartered plane. I said, really, how much is a ticket? He said, $12,000. It's like, no! I can stand on the ground for free. Another interesting effect are these things called Baily's beads. These were first seen by an astronomer named Francis Baily a couple of centuries ago. And these are basically, the moon isn't a perfect circle. It has craters and mountains on it. And so as it slides across the sun, right at the edge of the moon, sometimes a little bit of sunlight can peek through, and you get these flashes of light as you can see in this picture. And if you get a very bright one, it's also called the diamond ring effect because it looks like a ring around the moon with a very bright diamond in one corner. There may or may not be these effects when we see the eclipse this time. One problem right now we're having is that the sun is very quiet. It goes through cycles of activity, and it's not doing a lot right now. So we may or may not see a lot of these prominences and other things, but we might. There were some sunspots a few weeks ago that were popping off all kinds of storms. So we may see something like that. You never know with the sun. It's in some ways unpredictable. This is something I'm absolutely going to try to do. If you ever made a pinhole camera in like elementary school, you put a pinhole in the side of a piece of cardboard on a box, and what happens is you can project an image onto the back of the box. And it's not an easy way of doing things, but the first cameras were done like this. The pinhole makes sure that all the light coming in is parallel, which is basically what a lens does. So that pinhole acts like a lens. And you can look at the sun that way through a pinhole camera. But what's a leaf, right? If you have a leaf sitting out there, and leaves can have holes in them, insects chew on them or whatever, those can act like pinhole cameras. And so what you're seeing here is the shadow of a tree on a house, and you're seeing thousands of images of the eclipse. You can see those images are all curved. That is an almost total eclipse being shown hundreds or thousands of times through the holes in leaves on a tree. How beautiful and poetic is that? That's something I want to see as well. I'm gonna maybe even set something up to see if we can try to spot that. Now, there are a lot of misconceptions about eclipses. I've heard people say, don't look at them, you'll go blind. That is not true under any circumstances. I got an email from a woman from the great European eclipse in 1999 who was being told where she lived, which I want to say was Serbia, that there were policemen on the streets making sure people didn't look at the eclipse because it would kill them. That doesn't happen. People say, if you look at a total eclipse, you'll go blind. And if you ask them why, they say, well, there's that corona from the sun, and that gives off X-rays, and that can blind you. It's like, well, the corona does, in fact, give off X-rays, but the corona's always there, right? You just can't see it during the day because it's too faint because of the Earth's atmosphere is too bright. So in an eclipse, it can't blind you. That doesn't make any sense. On the other hand, and looking at the sun during totality is perfectly safe. The sun is being blocked by the moon. The corona is absolutely safe to look at. The problem is that as the moon is starting to block the sun, it starts to get darker out, and your impulse might be to look up and look at it. Nobody, as far as I know, has ever been permanently, totally blinded by looking at the sun. However, there can be permanent partial blindness or temporary total blindness. I think that's all the combinations you can do there. But nobody's ever been permanently, totally blinded. Looking at the sun is a bad idea. So if you should only do it if you have proper protection. You can get these. I had a pair and I forgot to bring them up on stage with me. But you can buy these inexpensive Eclipse glasses. They're literally like a couple of bucks online. Make sure that the place selling them is certified. Astronomers Without Borders is a place I like. They actually travel around the world and show interesting astronomical phenomena to people. So they're good for that. You can have a specially created solar telescope. That one on the lower left, that's actually mine. That's the one I took the picture of the sun earlier, the red sun with the prominence. These are rated good. Celestron has eclipse-safe binoculars. As you can see in that picture, the lenses of the binoculars are filtered to only let through a very tiny fraction of sunlight. I've actually used these. I have a pair. I was looking at the sun the other day. It's kind of weird to look at the sun with binoculars during the day. Every astronomy instinct in my body is screaming at me, telling me not to do that. Because if you do that without filters, you will boil your eyeballs. Not recommended by doctors. Another way is to take regular binoculars. Instead of looking through them, you can hold them up to the sun and project the sun onto a piece of paper. I did this recently. The middle right picture I took of some sunspots, literally you can see the shadow of the binoculars on the wall. Or you can do it the way a lot of people do on the bottom right, is just look at it on the web. That's fine too. But make sure you're doing this safely. You will see people saying, I just used a filter on my eyepiece of my telescope. Do not do that. You're letting all the light of the sun in through the telescope. Telescopes focus light. This is what they do. This is all they do. And you're taking the light of the sun and you're focusing it into a point. And what you want to do is block that light from ever getting into the telescope. A filter on this end of your telescope pointing upwards is fine. But at this end of the telescope, you're taking all that light and focusing it on a black piece of absorbent glass. And people say they've had filters explode doing that. You don't want to be looking at something like this and having the glass explode. Do not use those kind of filters. Some people say you can hold up a DVD and don't do that. That still lets through some of the infrared and ultraviolet light that can still damage your eye. Some people say exposed film for kids. That's what computers used to be, to take pictures. Don't do that either. That lets through infrared light. That can hurt you. Mylar, some Mylar is rated okay, but again, it's not a good idea. Make sure that if you're going to buy something, that it's by a good telescope company, a good place. It's rated safe for viewing the sun through that medium. And let me finish with one thing. My friend Katie Mack is an astrophysicist. She's the best. She is a master at tweeting. This has been repeated and stolen millions of times, but accept no substitutes for Astro Katie. She used emojis to show you what an eclipse is. Let's see here. Is this the laser beam? There we go. Yeah, so here's the moon. If the Earth is between the moon and the sun, then the Earth is blocking the moon, and you get a lunar eclipse. If the moon is between the Earth and the sun, the moon blocks the sun, and you get a solar eclipse. So what do you have if you get the sun in between the Earth and the moon? That's an apocalypse, right? For those of you wondering why everybody's laughing, that can't happen, right? The Earth and the moon are here, the sun's way over there, and in fact, the sun is actually far larger than the distance between the Earth and the moon. So if that were to happen, to make that real, the sun would have to be swallowing the Earth and the moon, and that would be bad, to coin a scientific term. And finally, just a few things. If you want information about the eclipse, honestly, if you type Eclipse 2017 into Google, you're going to find lots of good places. But Mr. Eclipse is Fred Espenak. I don't even know how many eclipses he's seen. He's got a book coming out very soon about eclipses that I wrote the introduction for. Astronomers Without Borders, one of my favorite groups. They are a nonprofit, and they travel around the world showing people astronomical phenomena. NASA, of course, is a good place. And there's a website called Great American Eclipse, which is actually quite good and has a ton of information. And let me finish by saying how jealous I am that you have an eclipse passing over your town. This is a precious and rare thing. Eclipses happen a couple of times a year somewhere on Earth, but on a specific place, a total solar eclipse, once a century, more or less often than that. The next total eclipse in the U.S. won't be for another 7 years. It's going to be east of here. Totally different places are going to see it. So if you can, take this chance. It is a literally once-in-a-lifetime opportunity. Thank you.